Hello, hello. Should be live. As always, I'm a couple minutes early, so I'm going to stick around, be talking as people are joining in, but it's more fun if you also talk. So say hello in the chat and maybe put where you're watching from, and also something about like why you're interested in building agents. Are you already building agents? Are you doing other cool stuff in the AI field? That's always really fun to share in the chat. So there'll be some links I'll probably share a couple times as we're getting started. Like I mentioned, I'm a few minutes early right now, and we'll wait a few minutes before we really get going into the content. But if you want to check out the code, this is a direct link to the code repo that we're going to be running from. So I know when I'm attending an event, I might want to grab the code, start running through things myself, or start picking around at it as people are talking. So you're welcome to do that. Again, I'll probably share this a couple times before we get going. And let me see. Let me double check that link is right. It should be, but I did update. Okay, cool. It is. And I'll share a direct link to the workshop repo. So there's actually a whole bunch of examples in here. Some are more polished than others. So if they are listed in the table, I think they should be pretty good. But I'm working on several other ones that I think are in runnable states, but I wouldn't do a workshop on them quite yet, but I will be doing them soon. So there's a whole bunch of like reinforcement learning I was working on with like Mujo Co environments. And again, it works, but I need to fine tune the policy to make the robot walk smoother, I think, before we do a workshop with it. So again, as people are rolling in, say hello. Also, I always like to double check that you can see and hear me. Seems like you should be able to. I guess as people are rolling in, let me also pull up a stream just to make sure. Looks like I'm streaming without crazy lag or anything, at least on my end. So that's good. So what are people building or learning? And today we're going to build a research agent, and you can take what we build and kind of extend to your own use cases, whether that's going to be building agentic research or building some other type of agent as well. I think you're going to see just different kind of design patterns that you can use. And I'll talk about this over again, probably, but we're going to be using LangGraph as the agent framework. Has anyone used LangGraph before? Or has anyone used any other agent framework before? Let me know in the chat, or let us all know in the chat. And I guess I'm curious now too with like, if you're using more Claude for coding and stuff like that, do you care as much about an agent framework? I think it's kind of an interesting question too. And then we're going to be using Flyte 2, which is the open source AI orchestration tool that we maintain at Union. I'm really excited because for this workshop, it's going to be the first time of me doing a workshop with Flyte 2 DevBox. Previously, I've done workshops with Flyte 2. They were on like a enterprise Union cluster. So we're going to use the open source today. It's my first time doing this workshop, so hopefully it's going to all go well. If you actually do want to follow along, there's going to be a little bit of setup. It shouldn't be too bad for you, but it should be fun. And then we're going to use Tavily for the search part of our agent. And we're going to get something that looks like this. So I'll just show you again as people are joining in. And I'll go over this graph a little bit later. And then this is Flyte running the Union UI here. So here's Flyte I have running as a local orchestration tool. It's going to build Docker images. It's going to run the workflows for me. And I get a lot of the reliability pieces built in here. The only thing we don't have really locally is the scaling piece. So people use Flyte to build really scalable and really reliable pipelines, AI pipelines or AI agents. And when you're running locally, it's just on my one machine, so it doesn't scale up to like a ton of machines. But we get all these other really cool pieces. And so you're going to be able to take this today and then leave and have and keep this kind of local environment that you can run your agents in. So this is a agent run that I just did before. Again, I'll walk through all the code and we'll show this again just as people are joining. And I'm going to kind of show what we're going to build. So here's a research pipeline. Comes up with a plan. And then it comes up with, in this case, we can pass on a parameter of how many research topics to do. And then these are going to fan out in parallel and actually do parallel research. Same with the actual web searches. So it's going to use Tavily, do the web search. It's going to run all these in parallel, so it should be pretty quick. You could scale this up. Like we have customers that use Flyte or Union, and they can run like, hundreds, or I'm not sure if we have one that does thousands yet, but it should be able to handle if you have the compute like thousands of parallel agents running at a time. So you can do massive amounts of work and then pass it back to, in this case, another agent that is going to evaluate the topic, but ultimately it's going to synthesize it and put it into a final report for us. It's going to do research, do all those topics. Each one of these is also its own React agent. Again, I'll talk about the architecture here in a couple minutes. We'll get going fully in like another minute or two as people have arrived in. I see a lot more people joined. So don't worry if you just joined, you didn't miss anything. I'm just kind of going over stuff we're going to build, but I'll go over this again in more detail as we go. This does the web search, and then, so you get a final report from all the topics that it searches out. And then we're also going to build a little UI. So at the end of this, you'll get an actual application that's going to be built in Gradio in this case, so you can interface with that run. So you can adjust like how many subtopics you want it to search. I'll leave it for 3 for this case. And let's say Flyte 2, if it actually finds it. I haven't tested Tavily on this. So again, if you're just joining, I'm just showing what we're going to build, and then I'm going to go through some slides, and then we'll go through and actually build this together. So I'm going to hit this research button now. And then this is going to give me a link directly to where it's going to do the whole research. Yeah, so someone said, good question. Do we have any prerequisites for this tutorial in terms of local environment setup? Yeah, so sometimes I'll try to run this in like a pre-built environment. Like Colab in the past is always really good. It makes it really easy for people to run, but you can't do Docker in there. So we're going to use this as a local environment. And originally this was going to be on a Union cluster, so I didn't send out setup instructions for anyone, so I apologize. But what you do want is a Python environment. I recommend using UV. It's what I've been using. It's great. If you already know how to install Python environments, then you can use whatever you want. I'm going to be using UV. It's also really, really easy to install on most systems. Like you just run one script on Linux or Mac, and then it's set up. And then we'll create a Python environment with that. And then the next thing is I'm going to be using OpenAI for the LM. So if you don't already have an account there, you can create one. You can swap this out for Claude later, but it's not built in to easily just give it a different key at the second. And then Tavily. Tavily is free to sign up for, and you get 1,000 credits. It's a search tool, so this is going to actually be doing the search, bringing in the information in. Again, free to sign up for. You don't even need to enter a credit card, and you get 1,000 credits per month, which is really cool. So really good developer plan. And then with that, you'll be able to build an agent and run it locally. If you want to do the extra Flyte part, which hopefully some of you do, you'll also need a Docker installed. This also should be very easy to install. And if you haven't done this before, I just recommend downloading Docker Desktop. And then this is going to build those Docker images in the background for you. But it's all going to be orchestrated with Flyte. So don't worry, you don't have to write any Docker files or anything like that. Hopefully, when this is set up, it's going to feel very incredibly easy for you to run this kind of production grade system with the reproducibility and reliability of like Docker images. And then Flyte gives you like retries, and we'll talk a little bit about infrastructure as context that you can give agents as well within Flyte, and you can kind of build like a self-healing agent. All right, so I'm going to go through the slides, and I'll probably go through these setups again, but I did share links in the chat. So again, Python environment is the main thing. You do want OpenAI key and then Tavily key. Tavily you can get for free. OpenAI, I don't know if they have free credits anymore when you sign up, but they did a long time ago when I did, but I'm not sure if that's still the case. But if you want to, you could throw in a couple dollars. And then, or you could look at the code and swap it out for Claude if you wanted to or something. And then Docker if you want to actually run the local development container. But again, if you don't install Docker, I'll show you also how to run the agent locally, and we'll still get actually a pretty cool terminal user interface that you can see the agent running. So a couple different ways that you can run this here. All right, so I'm going to go through some slides. And again, as people are joining in, this will be good. Oh, and because a lot of other people joined, this is the direct code link. So this actually has some setup instructions in there too. You can go ahead and start poking around on that if you want. So I know like when I'm joining somewhere or if I'm at an event as someone's talking, I might go set up my environment. So go there, look at the README. you can start running that. I guess you want to git clone it. That might not be in the README as well. And you would just git clone the entire workshop repo. So just run git clone that, and then change directory CD into the LangGraph research pipeline, which is in the README instructions. Is that cool with everyone? Right. So a quick introduction. My name is Sage Elliott. I'm an AI engineer at Union and Flyte. So again, Flyte's our open source, and Union is a company that I work at, and we're the core maintainers of Flyte, but a lot of other people contribute to it as well. So it's a really active project. I think there's something over 4,000 companies use it as their AI orchestration platform, including very big ones you've heard about. In fact, I can almost guarantee that you've used a model trained on Flyte, whether that's like listening to music, social media feeds, self-driving cars, pretty much healthcare, a whole bunch of different applications in different industries use like Flyte and Union to orchestrate their AI models. So call for everyone again is introduce themselves in the chat. Say hello in the chat. Where are you watching from? What are you building? It's always really fun to see what people are doing. And then I shared a link in the chat too for a Slack channel. So if you do want to do a more permanent introduction, there's an introduction channel there in the Flyte Slack channel. We've talked a lot about other machine learning stuff like ML News, other projects in there. Go check it out. I think also that has, it's getting closer to 6,000 people now. So a decently active community, really fun. Recommend checking it out. And then what we're going to implement today, so I kind of put this chart together, is what we're going to build. Is we're going to build an agent. It's actually 2 agents, so it's a multi-agent system. It's kind of a small multi-agent system, but it works pretty good. Is we're going to have an agent that takes a query, and then it's going to plan what subtopics it should search out. So we could say like, what are the latest developments in AI healthcare? And then it's going to come up with 3 different topics that it thinks would be good to search for that. So it's going to have topic A, B, or C. And by the way, it doesn't have to be 3. This can scale out to like 100 or whatever. There'll be a little slider that you can use to scale this out, or it could be less. So you could decide right now how many to do it. We could also change the agent where it would come up with how many to do it. But I had a little limit that we put in there. And then it's going to synthesize all the information. Actually, sorry, before it does that, so each topic is its own researcher agent. And this does React format, reasoning and action. So it's going to do a web search with the Tavily, get results back, look at those results, see if they're good enough. If it doesn't think they're good enough, then it's actually going to do another search again. And we give it some parameters of like how many times it can redo the search there. And then it gets that data. It's going to synthesize it, combine all of that into a report, write us a report like on the latest AI in healthcare, whatever we're passing in there. Then it's going to do a quality check and try to come up with like, are there any gaps in this research before I want to send it to the user? So if gaps are found, it gives it like a quality score. Then it's going to redo the entire search thing again. And again, we can give it a parameter of like, you only do this 2 times or 3 times, or don't do it more than once. And then it gets that data again, does a quality check. Hopefully it's improved. And then it's going to go to our finalized report. So this is what we're going to implement today. And you could use this again to extend to like your different agent applications if you haven't built something like this before, whether that's expanding it into a different research area or something else. Why multi-agents? So again, this is kind of a basic multi-agent today, but some of the other ones I built that have like way more agents that depend on each other are pretty cool. And why do you want to build with multi-agents? So there's like some things I probably won't read all this verbatim here, but like the task decomposability. So like the complex task can be broken down into smaller manageable subtasks. If you have a really big thing, this is pretty important. You probably have seen this when you're interacting with something like Claude Code. It's going to break down tasks and then call other agents to do those specific tasks. Parallel execution. This is a huge one in some applications where an agent can search, again, like we're going to see today, and parse results while another agent performs other searches or does another task entirely. And then you can do independent scaling so that that single task can scale up or scale down. So if you want to have like 10 search agents and 2 math agents or whatever all running at the same time, those are multi-agents, and then they can just scale up and scale down as needed. The agent independence, each agent can have a highly specialized focus prompt. And I found this to be pretty important sometimes, especially again, when you're doing more and more complex tasks. where you have a shorter focus prompt, and then you get a less likelihood of it kind of bringing in the other context parts that maybe you didn't need for that prompt. Durability, so retries, this is a huge one. So when you're thinking about like architecting a agent system, again, this one's maybe relatively simple today, but if our let's say our quality check step here failed, you'd want to be able to retry and then like restart just from this area without running all these other topics. So like if you just did like 100 searches, that was a lot of time, probably a ton of tokens that you used. So you don't want to start from zero again. You want to be able to be like, oh, I failed here. Let me retry this. And you might even want to be able to retry with adjusting the infrastructure. So if you provisioned, we'll see an example of this, but if you provision this with like too small of memory or too small of amount of CPUs to run its task, and it was like, oh, like I got it out of memory error. You don't want to start from zero or just fail there. You can actually pass that in with Flyte, like we'll see today. You can pass in like up your memory or up your CPU amount, and then it can scale up and then kind of become like a self-healing agent for those types of failures. And then reliability. So this kind of goes with the agent independence piece. But as like your tool list grows, I forget the current number of like the maximum amount that people recommend, but I think often when you're going above 10 or something like that, it gets harder for the agent to decide what tool to call. So usually I would break down my agents to have specific tools. Like you're a search agent, here's the searching the web tools. You're a coding agent, here's the coding tools. And then today we're going to use LangGraph. I'll share the link out here if you want to check them out. This is the agent framework that's pretty popular from LangChain. Has anyone used LangGraph before? And some people in the chat said, watching from Chicago, they're a graduate student, AI agentic pipelines is what they're building. Someone said, howdy from Silicon Slopes area of Utah. I was going to think that said Silicon Valley at first, but Silicon Slopes, I like that. I don't think I've heard that. Someone said Seattle, and they're building agents for digital marketing. Very cool. And then someone else also said Seattle, and they're just interested in learning. So again, let me know in the chat where you're watching from, what are you building? And in this case, has anyone used LangGraph before? Or have you used a different agent framework that you enjoy? Or have you found that you don't really like using agent frameworks? And then we're going to use Tavily. So again, sign up here for free. Should be very quick, and you can get an API key to use if you want to actually run this agent locally. And then we're going to use Flyte. So I'll just go through super quick some concepts that we'll see again in the code, but I'll break that down here. So Flyte 2 and Union AI, like I mentioned, Flyte 2 is their open source. So this gives you task level compute where you can define a task. In this case, you can think of a task as an agent. So we'll see what this looks like in code, but you can define this agent gets this amount of compute. And this can be important later. Like if you're building some of the small language models, you actually want to give it GPUs, or you're doing more memory intensive tasks and you want to provision way more memory, but you don't want to do that for every agent, maybe just specialized agents. So you're not wasting that amount of compute, and we'll see what that looks like, but you just do this directly in the Python SDK. You get retries out of the box. So if one of those agents does fail, I think by default it's going to retry 3 times. You can overwrite that more. And this can happen too on like tools. If you're doing a search or something like that, and you get a API rate limit failure or something like that, it's not just going to fail the pipeline. You can just wait and then retry it again. Get error handling. And this is where it comes in where I mentioned you could do like the self-healing agent architecture, where if you get an out of memory error, you can actually pass that in to the agent. And I'll show you what it looks like in code here in a second, but to say override what you're provisioned at the task level compute and give yourself more memory or give yourself more CPUs. And then obviously you can limit that. So it's not going to go crazy and spend all your compute budget or anything like that. Get containerization. So every task by default runs in a Docker container, but we also have this image spec and builder. So you don't build your own Docker container in the normal way. You're just going to define it in Python. What requirements do you want? You can add like apt-get and stuff like that, and then it'll automatically build it for you. Today in Flyte, we'll see it's going to build it for us locally. If you're using Union, you can build it remotely as well, which is nice. Caching. This is actually something I found really useful for debugging and iterating on agents too. If you are building a big pipeline and you are working on this like final agent down here, you don't want to rerun the entire pipeline every time. You can cache all this, which is also useful for other workflows. If you don't want to rerun something every time you rerun the pipeline, you get a cache state from it. But just for iterating on agents, I've actually found that to be really helpful. Just caching everything and then rerunning the pipeline, but just iterating on a single agent after the caching, which is nice. Reports. So we saw what that kind of looks like, where you get a report embedded in the UI, and everything is versioned. So every time you do a run, you'll get a version of the report, you'll get a version of the inputs and outputs between the entire agent. So this also gives you a lot of observability and traces on any of the tools it calls. You can do local and remote development, like we'll see today. Logs, reports, everything serialized between agents. You can do triggers, so you could have this research agent like go every 20 hours, start the research, and then give you some sort of result. And it works with most Python libraries. So even if there isn't like an official integration, it can work with most things. So you can check out the project on the GitHub, which is just Flyte, Flyte. Came out of Lyft originally. That's why it's spelled that way. All right, so I think I already talked about this. Just to show you what environment looks like, and again, we'll see this in our specific application today. So every task or agent in this case is going to have like this environment that we're going to define, and we can reuse this environment between all those different agents. But we define this with Flyte.task environment, and we give it in this case, we're passing a requirements.txt, and we're also going to give it secrets that we're going to set. So the Tavily key, the OpenAI key, and then we're going to give it some sort of compute. So in this case, the example here, which we won't use a GPU today, but it shows 2 CPUs, 2 gigabytes of memory, and 1 GPU. So again, this could be helpful where you might have one of your agents actually running a fine-tuned small language model or something like that versus OpenAI, and then maybe the other ones are running OpenAI. So you can define multiple task environments, and then when you write your code, you just add in a decorator. Here we define the env, and then we just say env.task as a decorator above a Python function. It works with async by default, which allows it to fan out. Again, which we'll see in action here in a minute. So this is what it looks like to write a task. It's just a Python function with that decorator. And then if you did use Flyte v1 before, you might be familiar. There used to be an @workflow decorator. That is no longer in v2. Now you just define another task, and the other task can call other tasks and become a workflow, basically. And there's no more DSL. So you just write pure Python. So you can write loops and try and catches and if statements directly in your workflow now, which allows you to do basically anything with agents or just more complex workflows that you might want to see. And again, everything is observable, all those logs, if you're here at the beginning, inside Flyte. Just open up again real quick. So inside our project, this is a pipeline run. So everything is logged here, all the inputs and outputs between every single task, all the traces for this. So this becomes a really good observability pipeline for your agents running as well. And then you can use a remote part of the SDK, pull all this out. So I'm actually working on a cool, I think it's cool anyway, monitoring and evaluation project. So I can pull all this out, and then you can see over time, like what was this agent doing. So that makes it really easy. Flyte traces, that's just a trace is a function inside of a task. So like this web search, this isn't a separate task. This is a function that's happening inside that research topic agent. But when you add a trace, you get the inputs and outputs stored as well as some of the durability pieces like retries and stuff. And how can we make it more durable? So I already mentioned you get retries out of the box. This is really great for like rate limits or API failures. This is usually what I run into. If you're calling some sort of API, especially if it's like a free public one and it's just not the most robust and it's down sometimes. So you can gracefully recover. It'll show you in the UI like, hey, this is all the amount of attempts I did, and then this is how I recovered. The error handling piece is really cool. Like I'd mentioned, I haven't seen this as much in other products where you can add in this infrastructure as context now is kind of what we're calling it. So we're saying like this first one failed, and then it's going to recover, and it's going to reprovision its memory. So it failed the first time because it only had 250 megabytes of memory. And then the time it succeeded is because it was able to up its memory. And you do that in code by just saying like, hey, you get this out of memory error. Now override the resources with 1 CPU and 1 gigabyte of memory in this case. So if you remember how we defined a task environment, we gave it the compute that it's going to run on, and you can override that. So really cool architecture that you can build these more really, really robust agents now and get that kind of self-healing piece, which I think is really cool. Has anyone seen something like that before or used something like that before? Right. So people want to go along and actually go through the code with me. Hopefully some of you do, or you want to come back later. That's totally fine too. If you just want to hang out and watch it, all good. I shared the link again. So if you do want to follow this along, oops, let me get just the workflow, or sorry, workshops link. So I would just git clone this in a repo. So I would just go like git clone, paste that in, and then hit enter. I'm not going to do it because I'm already inside my workshop repo, but that'll clone down the repo. Oh, someone said, can I share the slides? Yeah, hang on one second. Let me just share that real quick. Anyone with link can view. Done. Let me just grab that link. Thank you for the reminder. I know that people like them. There you go. I shared it in the chat. Someone said cool background. Oh yeah, my all my stickers. I try to get them at conferences, put them up here. Some people have sent me stickers now because of this, which is fun. I need to get more though. I still have more room. All right, so people who want to follow along, again, just clone down that repo, and then you're gonna go into. Actually, yeah, let me back up. So I'll show you the instructions. So I'm in my Git repos directory, and then I'm going to cd into workshops, which is what will be cloned down. Then I'm going to cd into LangGraph. So you can type, oh, sorry, actually it's under tutorials. And then LangGraph. I think there might be a couple, or there's a LangChain one. So LangGraph agent research is what we're going to do. And then if you follow along in this README, so actually let me go ahead and deactivate my environment even. I'll set this up with you. I already have Docker installed. So that is one thing. If you have Docker installed, again, it should be pretty easy. And you're going to need that if you want to run the Flyte dev box. But if you don't install Docker, it's fine. If you have a Python environment, you'll still be able to run a cool terminal user interface that will show you all the agents running. That is really, really helpful as well. So cd, change directory into that. And then you're going to create a new environment. So you just copy this in, paste it, uv-ven.venv --python 3.11 is going to work for this. And then once that is created, so you just copy that into your terminal, and then I already have that. So I'm going to go source.venv ben activate. That's going to activate my Python environment. Hopefully many of you have done Python environments before. And then you're just going to run pip install our requirements once you're in that .venv, and then that should install everything. One thing I've noticed sometimes with UV, and I think this is more if you've already been using projects with like Flyte or different libraries, is sometimes you want to rehash the terminal, and that'll reload kind of all the pointers to the direct Python to the correct Python version inside your directory. So if you do run into like an error, that's just been something that I've done several times. And then if you're going to run this locally, is you want to create a .env. So you can do that in your VS Code, or you could do it in the terminal. Create a .env, and then you're going to paste in. You could just copy this into your .env, and then replace this part, your key, with your actual OpenAI key and with your Tavily key. And then we should be good to go to start running things from the terminal here. Again, you need Docker for the full DevBox experience, but to run the TUI, which I'll show you right now, you actually don't. So let's take this, and I'll go through the code here. Let's run this first, and then I'll walk through the code. So inside my terminal, I'm going to go ahead and say, oops, that might have copied in weird. Let's see if this runs. If not, might have got an extra space. So I'm going to say Flyte run local, and then I'm going to pass in TUI, which is the terminal user interface, workflow.py, which is a Python file in here, which I'll look at. I'll show you what's in here in a little bit. But this is where the pipeline lives. And then we're going to pass in a query. What are the pros and cons of electric vehicles? And then I'm going to say num topics 2 and max searches 1 in this case. And I think I fixed this, but if for some reason you have an older version of the README, I think I merged it. It might have had this, like a instead of an underline. So make sure it's switched to an underline. If you get an error, that's why I think I merged it. But in case I did not, that might throw an error. Say num topics doesn't exist. Oops. Invoking command. What did I do? Stupid. I think it might have copied in bad. Let me see. Right, yeah. So copy that one. The other one should work too. I think it just had an extra space. So this is bringing up a terminal user interface, which you get just in the Flyte SDK without Docker or anything like that. You can just pip install Flyte bracket TUI, and this is going to give you this really cool interface here. So it's kind of a scaled down version of what you saw earlier in the dev box, where we can see our whole run. We have this pipeline, we have a plan, we see these research topics happening. I can actually drill in and see what's going on here. This is really, really cool. Like, I don't know if you've done a lot of multi-agent development before, but if you have more than a couple agents doing something, it's really hard to see what's going on with just logs. So having some sort of interface to see the status of everything and then being able to look at the results directly in your terminal is really, really helpful, has been really helpful for me, like developing agents and seeing like what is going on here without crazy logs getting in the way of each other. So we can see our whole agent's actually running now locally. And again, no Docker or anything here. In the TUI, when you're running this just with Flyte local, you get the TUI. So you get this kind of scaled down interface of what we saw here in Flyte. You also get retries. So we'll try to do like retry automatically 3 times. If it fails, you can up that. You get caching. So you can enable caching as well. So again, if you're iterating locally, you can enable caching on a specific task or in the entire workflow. You also get reports. They show up as a HTML file. So you'll be able to click on this. I think one thing I need to fix in the terminal is actually specifically in VS Code is making this easier to open. Or sorry, that's the output path, not the actual report path. This is the report path, so you'll be able to open up this HTML, and you'll just get a local version of this. One thing I need to make, again, is make sure that it's clickable directly from the TUI here. Sometimes you can click on it, but it'll like open up in VS Code, the actual HTML. But it's all there. And then you can go and see, again, the inputs and outputs for all of your agents directly in the terminal. So I think this is really cool. Does anyone else think this is interesting, or do you think that would be useful for agent development locally? And then I guess I'll show running the dev box and then the code, if that works for everyone. So to run the full dev box now, and we'll come back to this, but this runs that Gradio app that you saw at the beginning, if you were here, that just gives us the interface in. So you can run this local mode, and this would, I guess I will actually show this. Let's quit out of there. Let's run this. This is going to now give us our Gradio app that's going to be running completely local, not in Flyte dev box either. And this will interface with just the local version of the agents. So I'll just click this. I'll hit research. This won't spin up the TUI, but if we go back to the terminal, we can see that everything's running in here. And then we'll actually spit out the results as a report directly in the Gradio interface. But it doesn't give you the persistent stuff like you get in the TUI here. So let's go to the next one. Is we want to run this on DevBox. So if you have Docker installed, you should be able to run just Flyte start DevBox. For me, it's already running. But if you run this for the first time, it's going to take, it's not that long, but it might take a few minutes to download like the latest version of the container for Flyte, and then create a local little Kubernetes cluster that it's going to run on. And then it's going to start up, and it'll give you an IP address. And then you can go to that IP address, and you'll go to, it'll actually be this. So once it starts up, it'll give you this by default port 380, or sorry, 300, and then 80, not 380 though. And then it will give you this. This has project folders. You can create new project folders. By default, there's one called Flyte Snacks. It's kind of the default place to experiment and where things are going to build, but you can add new projects. We can click into Flyte Snacks. We can see all my research pipeline runs for this project. I can click in. Yours will be empty until you run one here. But once you get the UI, everything should be good to then run the task in there. Actually, sorry, I forgot. You got to run this before that. You can copy and paste this directly in your terminal. this is going to create a configuration file. And I'll show you what that looks like. So we have this .flyte that's going to be created by default, and then go into this config.yaml, and you'll see that this points to this endpoint. It's going to say right now, build the Docker images locally on your own Docker. This is the domain it's going to connect to, and this is the project it's going to connect to. So there's different domains, like you have a development, production, what's the middle one? Like the other experiment one. It should be in here actually. Development, production, staging. So you can push these projects to those different domains. Like as you're testing, it could be in development before you push to staging and then to production. And then you have different projects. And then if you do have a actual deployed Flyte cluster or a Union cluster, and you're iterating locally on your own dev box here, but then you want to update this, all you do is just change this config, which you can either do with this command like this, with those other values, or you could just update it directly in here, give it your actual endpoint, and then it'll start building and pushing everything there. So once you've done that, now you should be able to actually run a task on, oops, let me go back to the README, on your Flyte cluster. So if that ran, if you do run it first, you'll get an error because you didn't set these API keys yet. So you can copy this in. This is going to create a secret that's then managed by Flyte. And again, you could do this in Union if you actually have a remote deployed cluster or with Flyte. So it manages secrets in there. And then when we'll see this in the code here in a second too, but inside the task, we actually read in a secret with a name and then what it's going to look like in that environment when it's read in. So you can also have different secrets for like production and staging. That's very common, also for different projects. You can also have global secrets. So instead of mapping to a specific project, you can have it mapped to like all the projects in your domain. So run this and then grab your OpenAI secret and then paste it in here. And then you'll have a secret set, and then do this with Tavily. It's going to ask you, paste it in, your secret will be set. So again, you have to go to your Tavily account, hit where's new API key. It's just this little plus button if you don't already have one. OpenAI, go to the API platform, and then create new API key, create one here, get that, and then you can just copy that in here. So now that that's set, we should really be ready to run this on our cluster, our little local cluster. I'm going to clear my terminal. Hopefully this copied in better than last time. And for me, again, it ran almost instantly because I already have the container image built. If it's your first time running, it's actually going to build that container image with Docker locally. And in the code, this is what it looks like. We've just defined our container in this way. We're going to use a base Debian one, and then we're going to pass in that requirements.txt, and then those secrets. And then we're going to say provision this amount of CPU and this amount of memory for that task. You can pass in a GPU here too if you have one locally with CUDA, which is also nice. I do that on my DGX Spark. I've been using Flyte DevBox as just like my home AI lab system now, and it's really, really nice. So no Docker file. I don't know if people like writing Docker files, but now I can just do it all directly in Python here. And then it's going to look at this inside the task where it's defined, and then build that container if it doesn't already exist. If it does already exist, it's going to say that already exists. I don't need to build it, which mine did. We can open it up. Mine's already done running. You can rerun it from the UI. I'll rerun it from my terminal real quick. I'll click on it so you can actually see it run. And there we go. Super quick startup time. The plan was done. That's a trace here within the research pipeline. And then it's just spinning up now these research topics it's doing in parallel. I think, do we say two topics, 2 searches maximum, and then 1 iteration maximum. So it's just going to do this planning. We can see that this is part of LangGraph. Again, I'll walk through the code. You have the link. You can also be looking at it. We can see agent. There's a thing in LangGraph. So we have agent defined, and then should continue is like one of the edges in the node. So it says should continue to tools. It's going to call web search again. And then it's going to say should continue to end, basically. So we're logging all parts of the LangGraph system here, which is kind of nice. Someone asked, what are we giving in the requirements.txt? Thank you for calling that out. I did have it up here. I meant to show it earlier. Here we go. So we're passing a LangGraph LangChain is a requirement for LangGraph. This might already, this is a LangChain OpenAI one. So we're using OpenAI inside LangGraph. We're using Tavily, Python API for that. Flyte TUI. So if you want that terminal user interface, make sure you have this. It's going to install a textual, which is the requirement right now for the TUI. That might change in the future. And then it should be over 2. So 1.0 has been around for a long time. 2.0 is what you're seeing right now. Markdown, python.env. So this uses, we use this to read in the .env variables. And then union reuse. We're actually not using this today. And then Gradio. So Gradio will give us the app that we've already seen a little bit, but we'll see here again in a minute. All right, so we were able to run our task. One thing we want to do is also basically register our task. And this allows us to, like, you can be iterating on it like we did, where we're passing this in. Now we think, cool, this looks great. This is something I want to be able to call remotely from something else, like a Gradio app or something else that's deployed into my system. So we can say Flyte deploy workflow. Again, we'll look at the code here. I think it's easier to just go through this and then dive into the code. I'm not sure. Workflow.env. This is the workflow environment. Again, show you the code here in a second. Now this is a registered task. So we go in the UI. We have this task tab here. These are all tasks now that we can call or set on triggers to, like, run a certain amount of times, or run at, like, certain times. And then we can run the app locally. So again, we're kind of showing you all the variations of, like, completely local. And then this is going to be, the Gradio is still local, but it's going to kick off a task inside of the container now. So I'll just click one of these. It's going to give us this link to the local container. And then we can see, oh, cool, this is running now. And then the next part is we can actually deploy this app on the Flyte cluster. So this is all local right now with our cluster. But a cool thing about deploying is if you're actually on a, I can type now. If you're actually on a remote cluster, this will give you, like, a remote URL that other people can access this app. And you can say auth is equal to false or auth is equal to true. And if people are in your cluster account, then they can have access to this app. Another nice thing about the app being deployed directly in your dev box, though, is that it does have auto scaling. So it's, right now it says replica 0 of 1. Then this should spin up to 1 of 1. When I click on it, it'll just take a second because it was all the way scaled down. And this is actually really useful, like on my DGX Spark, when I use this to manage models. It automatically will spin down resources when I'm not using it. So if a model is loaded into, like, GPU memory that's just kind of burning compute, after a certain amount of time that I can define in the code, it'll just spin down. So now this is all running in our dev box. So complete emulation of, like, a remote environment, but this is locally on your dev box right now. You can even have a dev box set up on a remote thing, like I mentioned in DGX Spark, and then I use, like, Tailscale or VS Code tunnels to remote into it, and then you get remote access to your apps and models, which is really nice. And then if I click this, it's going to kick off the job again. And now I'll go into all the code. But what are people thinking so far? Is this interesting? We have this whole cluster running. We have this awesome UI where you get all of your agents running. We have apps now that are hosted also in here that auto scale up and scale down. Again, if you're on a cluster with multiple, with a lot more compute, you can actually have the scale up replicas too. And another nice thing that I see more people talk about now is actually, like, kind of environment skew drift, where you're building your Docker environments. They can be the exact same one for, like, your, in this case, maybe it's different for the agent, but it's pretty common in cases where you're training a model for, like, doing batch inference while training, but then you're deploying it for, like, real time. In this, you can manage your environment and Docker containers simultaneously, like, all in one platform. So you get kind of rid of some of the environment skew stuff, which is also really helpful in some applications. Maybe not as much for ours today with just the agent thing, but if you're doing things with, like, feature stores and stuff like that, it's nice to have everything in one platform kind of interlinked together. And inside of an app here, you can pull directly in a model. So if you're doing, like, a model training pipeline instead of an agent, and the artifact produced here isn't a report, but actually a trained model, you can just directly easily pull that model in to the app, either looking at, like, the latest version of that name or actually passing in, like, specific hash ID. So also really, really helpful. Like, having versions of everything here, which is awesome for agents, but this is also really, really powerful for any other ML training pipeline. Like you can go see the entire data flow that produced a model, and kind of be able to track exactly what's going on, which for some industries like healthcare and finance, that's actually incredibly important. I think for any industry, it's very valuable, but sometimes you actually need to do that. All right, so let's go through the code. It felt easier to go through, do the setup, show everything, and then we'll go look at the code. Not sure if that was the best flow. You let me know. So inside of our LangGraph agent research pipeline, we have these files. I'm going to be clicking into them. There's a README that kind of describes, again, how to do everything that I just followed along, and it worked good. It has a little bit more info as well. Check it out. Requirements.txt, we already looked at what was already in there. The config.yaml, we already looked at that. Again, you just change this if you want to run it in different projects or in a deployed cluster or on a Union cloud. We have this config.py. This is where I created my task environment that our agents, both of our agents are running in the same environment. Again, you can have multiple environments though. And I do this all the time. If I'm doing model training pipelines where I'm doing data pre-processing, that's all going to be on a CPU. Maybe I need memory to load it in, but I don't need a GPU per se. And then on the training piece, I actually do need a GPU. So you can actually be really specific about the resources you need, and you're not taking those resources from other people. And those like if you have a limited amount of GPUs right now, like a lot of people do, this is really nice to have. And then I'm passing in the environments that we set here, and the image gets built from that requirements.txt. Again, you can add in more commands here, like apt-get and all these other things. If you want to install more specific things outside of just like pip install requirement stuff, you can do all that. And then I also set my local environments here too. So we use that .env. It's going to read from that .env. And when I just ran it in the 2e, it's going to pull in the API key here. Then we'll go to graph.py. This is the actual LangGraph part. Let me minimize this. Some comments, again, showing the agent that we built. And just to reiterate, we had that nice graphic that shows the flow of our data. So we're building this planning piece, then these subtopics, which are their own agents itself, and then synthesize, quality check, identify gaps, and then the researcher web part, that's the agents within here. And then we're going to finalize a report for us to look at. So inside here, we have our imports, and we have our build research subgraph. So this is going to be that kind of, again, React part. And we're using GPT-4 Nano here, but you could adjust this depending on what you want. So if you want the Nano one runs really fast, but the quality isn't as good sometimes. That actually works really good for research here. I don't need the highest quality model, but you could adjust this for like maybe the report writing piece. You want to have a better model here. This is going to get our web search tool. Or sorry, this is going to create a web search tool. We'll look at this later, but it's going to pass in our Tavily API key. And then our tool that this agent can call is going to be web search, but you could pass in more tools in this list if you wanted to. And then our LLM is going to be the OpenAI chat. And then again, this comes from LangChain part, that OpenAI LangChain that we had added. And then we're passing in the tools. We say in LangChain or in LangGraph, you're saying bind tools and then pass in that tool list. And now it knows that this LLM can call those different tools and do tool calling. And then here's our prompt is, you are a research agent. Your job is to thoroughly research a topic by searching the web. Use the web search tool to look up, and then we give it a max searches variable that we passed when we called it. Times to gather information from different angles. After gathering enough information, write a clear summary with each findings and resources. So a pretty small prompt. You could adjust this to, again, maybe make it better depending on your needs. And then we have this Flyte trace on top of this agent. So that's inside. I'm going to go back and forth between the UI, I think, to show this. So inside, we have this agent, which is inside this research topic part. And the agent basically decides, should it continue to call tools or should it continue to end? And if it's calling tools, in this case, it's just doing web search. And then we have that on the should continue. Again, this is part of a kind of LangGraph's method of putting together this graph, and then those are the different states that it gets. And actually inside of here, if I go back to my reports, we have the report that it finished, but we also have the agent graphs that get built from LangGraph. So here's the little agent that we just built there. Basically, again, very simple. It's going to reason about searching, call the web search tools, Is it good enough? If not, it's going to call those tools again. And then when it thinks this is good enough information, then it's going to go to this end state. And this is kind of what it looks like in LangGraph when you define it. And then our other agent that we're going to define is this pipeline graph. And actually the visual might be easier to look at. So we have this plan state, research, which the research is going to then call the call this research agent. And then it's going to synthesize, do quality check, research more if needed, and finalize, just like we saw in the other graph here. So this is kind of a similar setup to before, just a little bit more going on. So we're creating our pipeline state, which has just more variables, max iterations, etc., all the stuff that we set. Then we have Flyte trace on the plan part, and the planning is the LLM again. Hey, break this research question into exactly whatever parameter we give it, three focus subtopics, return only JSON array of strings, nothing else. And then we give it that question. And then it's going to use that to create the search plan. And then we have this route to research. And this is actually a cool integration point between LangGraph and Flyte. Is LangGraph has this thing called send, which basically allows it to, that's kind of how they handle like fan out directly in their API. And what we do is we actually have another function that we'll see in the workflow tab that is a Flyte task. And it's going to basically kick off, send, and start that research task. And that's how it manages the parallelism of like doing these research functions at the same time. That's exactly how LangGraph wants to handle it, like in their API. So instead of doing anything weird and getting it to work, we actually just send to a Flyte task, and then it spans that out and it works well for running all these in parallel now. We define research. This is actually where it calls then the research task, which we'll see in the next one. Flyte trace on synthesize. This could also be a task. So sometimes when you're thinking, I actually might rewrite this as a task. But again, traces gives you the input output, also a lot of the durability aspects, but it runs in the same container. So if you did want to have a different model or something like that loaded in here, you might want to make this a task instead of a trace, but it totally works for a use case here. And then we do that again on quality check. So these are just the agents. These are the prompts like, hey, rate the quality. Quality checking like this, sometimes you want to be way more specific, like what actually determines quality. So you could have examples or saying like, if it has M dashes, then -1 or whatever in the quality of the report. So you can mess around with that. And then we have to finalize. So these are all just different little agent states. And then we build our graph, and that's the graph that we kind of saw down there. So this is a plan, research, synthesize, quality check, identify gaps, finalize. And then that gives us this graph that we just saw here. So that's just how we defined it in LangGraph. And then in workflow.py, we're pulling in the LangGraph agent here, but then wrapping it in like Flyte tasks and doing some other things like creating this helper function to convert Markdown to HTML for the report. And then we have, again, our tasks now are being defined here. We say report is equal to true. That allows us to have that embedded report that we saw. And this runs the React research agent on a single subtopic. So this is the thing that starts getting spanned out when we have that send API. It triggers this research topic, which is a task. And that's how we get all these agents running in parallel. And then we have the orchestration piece. So this is us bringing in this is other stuff about building reports. So the reports, like they're all HTML, and you also want to encode images into base64 to embed them. And then after that is let me find the part where the actual pipeline piece real quick. Was it down? It's in here. I built this, and then I did some changes to it. Where the pipeline piece. Oh yeah, so here we're calling the pipeline. Why am I not? I feel like I'm just not seeing what I was looking for here. Real quick, find it. Oh, I think it's actually because not everything was a task. That's why. So I want to go rebuild this. Like we're saying, this fans out this as tasks here. Everything else is actually just one agent with a trace on it. And usually when I build a pipeline, I have different things as tasks that get chained together, but we actually all did that in the LangGraph piece, and then we're really just calling it from this pipeline invoke here. And the reason why I was confused is I redid this in pure Claude without a framework, and that's how I did it with the tasks in the pipeline. And I did this the other day, and that's what I was looking for. My brain got confused. But yeah, if you have that workshop link and you want to see, this is very similar here, just using directly with Claude instead of agent framework. And that's basically our code walkthrough. And that's how we got this agent that is now really durable with all those features that we saw baked into Flyte. And again, if you deploy this on something like a union cluster with Flyte or your own Flyte cluster, kind of infinitely, as long as you have the compute, scalable for whatever you need now as well. Any questions or thoughts? The chat has been a little quieter than normal, but I see quite a few people watching still. Is anyone going to try building something with DevBox or with the Flyte 2e? I really like the Flyte 2e stuff too. If you don't even want to set up DevBox, just having the terminal user interface for agent development, I found that really, really helpful. And if you have feedback on it, let us know too, because we're making a lot of improvements to the 2e, to the DevBox, etc. I think I mentioned this before, but one thing you can also set up, which we didn't do here, is triggers. So you could have an agent or whatever it is just run on a set time, or you can have some other triggers, like if a file changes or something like that, run. And the 2e, you're just purely Flyte local. You can also interact with Flyte plugins, which is cool, even without the DevBox. And you can also do alerts as well. So you could have this run every 24 hours and then integrate with your Slack channel and give you the results there instead of being directly in the UI, which is nice too. So a lot of ways to kind of interface with agents and then also bring that data out in different ways. Someone said very cool. Then we'll give it a try today. Let me know what you think. If you have questions or get stuck, ask us in the Slack channel. It's going to be the quickest way to probably get unblocked. And would love to know if something comes up for you. So someone said, how expensive is it to use agent orchestration for research? I think it depends on what you're doing. So, I mean, the orchestration here in Flyte is, like virtually free if you're just running it local, like in the DevBox like this. But it depends on like what you mean. If you're scaling up a ton of agents, that's going to look a little bit different for you. And then also, how are you scaling it? Like if you're doing, if you're using OpenAI API versus running a local model, that's also different. It depends on it, which is more expensive, depends on what you're doing exactly. Like if you're going to send a ton of requests to something like OpenAI, at some point, maybe using a local model could be cheaper, but also if you're not, there's going to be some trade-offs to that in terms of cost and just time. So I think, I don't know how to answer that. Like there's not one number I can give you. Depends on what you're doing. Do you have more that you want to add? Like are you doing research and what does that look like for agents? Someone said, sorry, not sure if I already said this. They were distracted with work, but is there a way to set the domain it uses for research? For Tavily, is that what you mean? I think Tavily might have. Let's see real quick. I don't know if that's what you're talking about. I actually don't know if they have. They have some really good examples. Let's pull it up and see real quick. So I know I've run different I've run it for different use cases. I'm not sure if this is what you're talking about, by the way. So let me know if you're talking about something else in the chat. So if setting domain in our case was we just passed in a specific prompt, but you might be asking like specifically for looking at archive maybe or the domain knowledge space of like just healthcare or something like that. So in Tavily, you can check out the docs and they'll tell you more than I know off the top of my head. But you can, I think, set like specific domains, so you can like extract out from, in this case, Wikipedia. They also have this crawl web pages, so you could give it a URL, I think, to like archive or something like that, and then crawl there, or map web pages. So if there's like a domain, this might not be what you're looking for, but if there's like a domain tag inside of like archive or something like that, I think you could have it mapped there. And then they actually have this own research task, which does some of what we built today, but you don't have full control over it. So it's kind of their own research agent. But I don't know if this does exactly what you're looking for. But there are different things you can do with Tavily. I've done some of these before, but I don't know if there's like a specific domain feature. Like if you're asking about just healthcare, I don't know if it has it as like a specific knowledge store. Otherwise, you just pass it as a query though, and it does from my use cases, it's done a pretty decent job of having like relevant, pretty fresh knowledge. There's also other search APIs that you can use, like Google has one. Brave is one I hear is pretty good. I haven't used Brave yet, so you don't have to use Tavily, but it is really nice to get started with. And I like their free developer tier of 1,000 credits, so I like to use it in examples. There is a DuckDuckGo as well, but that one is not nearly as good as something like Tavily or one of the other research APIs. And someone also clarified more on the expensive in terms of token usage for the researching agents. They have been seeing posts on LinkedIn where people have spent $200 per query on multi-agent workflows, but your point on having local models makes sense. Yeah, so like it just depends on what you're doing. So if you're spanning something out and doing like hundreds of research agents at the same time, that can get really expensive, especially if you're using the more expensive models. Like we were using a really cheap one from OpenAI too, the Nano one, which works fine for our use case here. But you might want to check out using like GPT 5.5. I don't know the pricing on that off the top of my head, but it's going to be way more expensive than like the Nano one. I don't know if they have pricing. They have pricing on the models directly in here. I'm not sure, but I've been using more local model stuff too for some longer running research. Again, depends on use case. It may not work well for what you want to do. But if you have the means to run a model locally, like a GPU, that can be really helpful. And it might be really helpful for you to like use it while you're building and debugging before you actually kick off like production workflows using a way more expensive model. I've been running Gemma 4 on a DGX Spark, and it's pretty good. Like it's definitely not as good as using like Claude API, which also has more of a harness around it. But it does a really good job on certain things. Like if you do want it to make a plan, and like doing this planning part of this, obviously this one would do a really good job. But if you have a more complex thing, it actually does a pretty good job of coming up with complex planning. Coding is okay on it, but not nearly as good as some of the other models from just my experience. I don't know what the benchmarks are officially, but just what I have found on it. Especially if you're passing in a lot of context that it wasn't trained on originally, like having it write something that wasn't in its training memory. It for me, it was like almost had a little bit more of a bias to like its training versus context that was passed in. So that was interesting on Gemma 4. But you could also break up your workflow. So you could have a local model doing part of your agent, and then you could have a more expensive model just doing another part down here like once, and that would also potentially be way cheaper. Oh, and so it said, maybe dumb question, but what do you mean by local model? Yeah, no, not a dumb question. So you can, like for me, let me see if I can actually pull this up even. Might not be remoted into it. Oh, I don't think I am. I think I have to log back in. So I won't pull it up, but I have another version. I have a version of Flyte running on a DGX Spark. So you can bring up, like I have a model running locally in my home on a GPU versus me paying someone who has a hosted model. Because otherwise you are paying per token usually. For me, I obviously still pay for electricity that powers my model. That could add up over time, but it's often way cheaper if I'm just doing like some queries. So I have a model that's downloaded, running on my own hardware. And then once that happens, I don't really have to worry about paying for anything except for the electricity on it. And so that's what I mean by a local model. Yeah, and someone said they like Gemma, but for coding, Quinn is my favorite local model. Yeah, I think that's kind of what I was finding when I was building with Gemma 4. And I was even using the 31 billion dense model too. And it still wasn't perfect for coding, but I really like its thinking and reasoning. So it's really good for like planning and looking at stuff. But the coding wasn't as good as I think the Quinn that I had going before. Again, for my just personal stuff that I was working on, maybe different tasks it does better or worse. Someone said, can I explain what LangGraph is for? So LangGraph is, we can actually even go to their site probably too. So in this case, I actually have a blog post that I'm probably going to publish tomorrow that will talk about kind of the differences between LangGraph and Flyte in this case. So LangGraph is a framework. Also, they've renamed certain things to LangGraph in the LangChain ecosystem. So LangGraph, as I'm using it, is basically a framework. So if you've used something like Crew AI before, Llama Index, those are all pretty popular agent frameworks. So LangGraph is one that I think is one of the most popular ones, and it basically gives you conventions for building agents. So we went through our code, like we have stuff that we imported from. Oops, sorry, that's the Claude one. I keep getting confused. Open up graph.py. LangGraph gives you conventions to basically define the logic of your agent. So we import things like state graph, these nodes, send API, and then that's how we structure the logic here. Like when we built this little React agent here, we give it this graph that we built that we looked at. We say, let me actually pull that up again inside my Flyte report. This is what we want to build. So we define the logic of these agents inside the LangGraph framework, but in this case, it all runs in the compute that's orchestrated by Flyte. So it's also confusing because people use the term orchestration now in different ways. So orchestration often meant before LLMs and agents, like defining the compute resources and Docker images and then orchestrating that to run something. Now, sometimes people use the term orchestration for like something like LangGraph as well, where you're defining the logic, but then you still need to orchestrate the compute to run all that logic. And so LangGraph just gives you a way to define it in Python that some people really prefer over not using a framework. And then maybe it's easier to write or easier to understand. And then this all spins up compute on Flyte or Union in this case. And so it said, thanks for the tutorial. They'll be trying it today. We'll reach out on Slack if needed. Awesome. Thank you for coming in. Let us know how it goes. I'd love to see if you like running DevBox. You can also check out all the other stuff that we're doing at Union. And if you thought it was interesting, like what you saw in Flyte, and or you want to run this on Union, which has more like scaling features, some other features like long running containers that are really cool for running things incredibly fast. If you want more of a personalized demo, or just you want to talk to us more about how it could work in your use case, you can fill out this chat with an engineer page, a box. Someone said, this was great. Thank you. Thank you for coming and talking in the chat. And again, if anyone has any questions, I know we're over time now. I still see people hanging out, which is awesome. So if you do have any questions, let me know. But I do have to end this soon as well and go to another meeting. So join the Slack channel if you haven't already. Say hello in there. I'm in there a lot. I share a whole bunch of other stuff too. I'm a lot of other people from Union and just the community in general. So join it. Say hello in introductions. And hopefully I'll talk to you all later. I'll hang out for another couple minutes, but then I do got to hop to another call. And again, if you want to come back and reference the code at any point, you can go to the workshop repo. Was there anything else I needed to share? We have lots of other events coming up. So if you already RSVP'd on here, you'll probably see them on Meetup or Luma next week. I'm doing one on computer vision. So not an LLM thing, although it is using detection transformer, which is a different type of computer vision model that's a little bit different than like a convolutional neural network, but it works pretty similar. But it uses an attention layer to look at pixels for object detection. So if you think that's interesting, you can also go to the event section on Union and see all the other upcoming stuff that we're doing as well. This is, I guess I can click in specifically to the Dieter one. I think this will be really fun. We'll build our own object detection model. So you could also take this and put in your own data and then fine tune it on it and then have your own model do object detection for your dog or something like that. A lot of people have pictures of their pet. So I often see like after a tutorial like that, people will train it on their own like pet, which is kind of fun. All right. People are saying thank you, and I think dropping off. So yeah, I'm gonna end the stream. Thank you everyone for coming out, and hopefully I'll talk to you all later, either at another event or in the Slack channel. Try out the dev box. I'm really excited to see what you think. I think when you get it set up, which should be pretty easy, again, just install Docker, install the Flyte SDK, and then it's been pretty seamless for me to run everything directly in here. And you can even set up on another machine and then SSH into it like I did with Flyte on my DGX. It's really, really cool. I've been using it for training models, for agents, and with this, with like a GPU at home, has become just a really, really cool home AI lab for experimentation and getting production level logging and reliability. And then just the versioning, being able to go see what hyperparameters or data I passed into a model, how it got those results is really cool. All right, I'll talk to you all later.